at example 2, we're going to solve an equation by completing the square. So you can see I have x squared minus 6x plus 12 equals 19. And one way we've talked about solving these before would be to subtract 19 and then try to factor it. The other way we can do this is by completing the square. So to complete the square, remember, you need to have one side that's just x squared plus bx. And I can say I have x squared minus 6x, which would be in this form, but I also have this plus 12. So I need to get rid of this plus 12 before I can work on completing the square. So I'm going to subtract 12 from each side, so I get x squared minus 6x, and I'm going to leave a little space so I can complete the square, equals 7. Because I've got 19 minus 12. So now I'm going to work at completing the square. I know that b is 6. Negative 6, sorry. And then 1/2 b would be negative 3. Again, just following my steps, looked at the coefficient, it was negative 6. 1/2 of b would be negative 3. So then I have to square that. Negative 3, and make sure to put in parentheses, squared would be positive 9. You will always be adding, so this thing you square should always be positive. So I get x squared minus 6x plus 9. But remember, anything I do to one side of an equation, I have to do to the other side. So you actually, when you complete the square, you add 9 to one side to complete the square, but you have to add 9 to the other side in order to keep your equation balanced. Okay, you cannot just add something to one side. Anything you do to one side, you have to do to the other. And this actually will work out pretty nicely because now I have x squared minus 6x plus 9, which will factor as x minus 3. Notice I had a negative number here, so I'm not adding 3, I'm subtracting 3. Squared equals 16. And what makes this so nice is I can now solve this by just taking the square root of each side because I have a perfect square on one side, and look at 16. It's a perfect square on the other. So you remember we used this strategy to solve some quadratic equations. We can use it here. We can take the square root of each side. And remember, when you take the square root, you have to account for a positive and a negative. So the square root of x minus 3 squared is just x minus 3. And that could equal positive 16, but it could also equal, or positive 4, or negative 4, because we're taking the square root of 16, which is 4. But remember, we had that plus or minus 4. So then I have to write my two equations. X minus 3 equals positive 4. X minus 3 equals negative 4. And solve each of them. Add 3 to each side. I would get x equals 7. Add 3 to each side. I would get x equals negative 1. And there are my answers to this problem, which we solved by completing the square. We got it into a form that was x squared plus bx. We completed the square, but when we completed the square, we had to add it to both sides. We had two sides that were perfect squares, so we took the square root of each side, got x minus 3 equals plus or minus 4, set up our two equations, and solved, and got our two answers, x equals 7 and x equals negative 1.